Hello, Form 2 students. Welcome to our mathematics lesson. And today we are going to continue with the topic trigonometry. And this is our lesson number 3. Our topic for today is the sine of an angle. I'm your teacher, Mr. Wanyoike from Maryhill Girls High School. Welcome. Just to remind you what we have done in this topic, trigonometry 1, we started with Pythagoras theorem. And you remember we came up with the Pythagoras theorem equation, which is hypotenuse squared is equal to a squared plus b squared, such that if you want to get the hypotenuse, you get the square root of a squared plus b squared. We have also discussed SOHCAHTOA in our lesson number 1. And using SOHCAHTOA, then we can be able to get various trigonometric ratios as may be required in various questions. So today we are discussing the sine of an angle. In a right-angled triangle, the sine of an angle is the length of the side opposite to the angle divided by the length of the hypotenuse. The abbreviation of the sine of an angle is SIN, and we say sine theta is equal to opposite side divided by hypotenuse as shown in this diagram. Now we can use the formula for sine of an angle, which is opposite of a hypotenuse, to work out various questions or tasks involving questions in angles and the length of a right-angled triangle. In example 1, we'll find the sine of angle 35 degrees. Remember, the sine of 35 degrees can be calculated if you have the sides. You can also use a mathematical table, the 4-figure table, or you can use a scientific calculator. The one we said must be in degree mode and must be the one recommended by NEC, that is FX82MS Casio. In this example, we want to find the sine of 35 degrees. And therefore, we say sine 35 equals opposite over hypotenuse. The opposite in this triangle is 2.8 and the hypotenuse is 4.9. So when we divide, because sine 35 will be equal to 2.8 over 4.9, then we get 0.5714, correct to 4 decimal places. Example 2, what is the length of R in the triangle below? For us to find the size of length R, we need to still use our formula sine theta is equal to opposite of hypotenuse. So we say sine 20 degrees will be equal to opposite, which is 10, divided by hypotenuse, which is R. And when we cross multiply, we get that R sine 20 is equal to 10. And we can now divide both sides by sine 20, so that we are left with the unknown R. And therefore, R is equal to 10 divided by sine 20, which will give us R as 29.24 meters. Students, now there is some classwork for you to attempt. You can do them in your exercise book and post the work in our Google Classroom platform. And then we'll continue after that. You may pause to do your work. Students, sometimes you may have the sine of an angle and you want to know the angle whose sine you have. For example, if you have the sine of an angle x to be 0.7636, you can know the angle using two methods. One, you can use the mathematical table, and number two, you can use a calculator to do that. Remember we said you need to follow the instructions given in the question. If the question says use a mathematical table, strictly do that. If it leaves it open, then you can use a calculator or a mathematical table. Now, for us to get the angle whose sine is 0.7636, we need to say the sine inverse 0.7636 will give us the angle, say, x. Now, this angle x, for us to get it from mathematical table, we need to go to the tables of natural sine as shown in the diagram. We have the table there. We look for the figure that is very close to 0.7636 in the many figures we have in the main columns. So we keep on searching for the number that is very close. Remember, sometimes the figure that are start with 1 point, but here we want the one that is starting with 0.736. The nearest to this is 0.7627, the one circled in blue in the main columns. Now, this being the nearest, it means we have some more sine of an angle to look for, and therefore we need to get the difference of what we had and the nearest figure we have. That is 0.7636 minus the nearest figure we have, which is 0.7627. So we get that the difference is 0.0009. Now, for us to take care of this difference, now we go to the additional column or the difference column. We want now to deal with the figure 0.0009, which is short of the figure we had. Therefore, in the additional column, we look for that figure that will give us the sine of an angle which is 0.0009. In the additional column, along the same law, where we had a 0.7627, we move across further to figure 9. And we find that the figure, that column is headed by the figure 8. So we pick this 8 and we add it to the figure we had, that if you look at the red arrow that is going back, that is giving us 49. And then we go up with the green arrow, we get the figure is 7. Therefore, the angle here, whose sine is 0.7636, is 49.78. Let us now look at an example of how to use sine inverse. Example 3. A ladder leans against a wall as shown below. What's the angle between the ladder and the wall? Now, the distance of the foot of the ladder is 2.5, and the height or the length of the ladder is 5 meters. And therefore, for us to get sine x, or the angle between the ladder and the wall at the top, then we'll extract a right angled triangle as shown, so that the hypotenuse is 5, the length of the base is 2.5, and the angle in question at the top, painted in green, is x. So we say sine x, because we want the angle x, sine x will be given by opposite of hypotenuse, and therefore sine x will be equal to 2.5 divided by 5. So we find that the sine of x is equal to 0.5. So for us to get this sine of x, then we need to get the sine inverse of the opposite that we divided by hypotenuse. So we say angle x will be equal to sine inverse 0.5. From our mathematical table, the angle whose sine is 0.5 is 30 degrees. 30 degrees. Example 4. The diagram below shows a cross section of a ramp. The length of the ramp is 30 meters and the vertical height it rises is 9 meters. What is the size of angle A? The diagram is already provided, so we need to go ahead and use our formula for sine, which is opposite of hypotenuse. Our opposite is 9 in this case, and hypotenuse is 30 meters, and we need to get the size of angle A. So we say sine A is equal to 9 divided by 30, which is approximately 0.3. And therefore we say angle A will be equal to sine inverse 0.3. And when you go to our mathematical table, the angle whose sine is 0.3 is 17.45. Therefore, angle A is equal to 17.45 degrees. Students, we have come to the end of our lesson today. I believe you have learned something new, and I also want to believe that you're going to press on to learn more. Now, here is some work for you to do. Do the needful, do the work, and upload it in our Google Classroom platform. Remember to indicate your name and your admission number on every page of your work. Ensure you capture a very clear image. Be blessed.
Feel the love he felt for us when he bore our sins. Listen to his words, let them come alive. If we know him as he is, there is peace in Christ. He gives us hope when hope is gone. He gives us strength shelter in the storms of life. When there's no peace on earth, there is peace in Christ.